Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello students, welcome back. Let us start the topic of ratios today. Ratios. What is a ratio? The different models found in ratios, the different concepts found in ratios. You'll have in plenty. Let us go in detail. Okay? Yeah. So, ratio. We can define the word ratio as ratio is comparison of two or more similar terms. The concept of ratio can be defined as the comparison. And when you say the word comparison, keep in mind that that comparison should be in between similar terms, similar types. Okay, so terms of same types can be compared. Okay with that? So, and few other points to be kept in mind are a ratio should always be expressed in its minimized form. And the next point is a ratio will never be negative. A ratio will never be negative. So take a point. The first point. A ratio is a ratio is the comparison of two or more similar terms. Two or more similar terms. First subpoint. A ratio should always be expressed in its minimal form or minimized form. A ratio should always be expressed in its minimal form or minimized form. Next subpoint, a ratio can never be negative. A ratio can never be negative. Now to the screen, please. If x and y are similar terms, then the ratio of x comma y would be given as x is to y, which is x over y. So we write x is to y as x over y, x upon y, whatever it is. And the term x is technically called as antecedent. Antecedent. Y is called as consequent. Of course, I accept x is called as numerator, y is called as denominator, but the key word is antecedent and consequent. So if x is to y are the two terms, if x and y are two terms, then the ratio of xy is x is to y or x over y, x upon y, where x is called as antecedent, y is called as consequent. Now, based on this, take an example. So, if A is to B is to C, if A is to B is to C is same as 2 is to 3 is to 4, is same as 2 is to 3 is to 4. The value of A, the value of B, the value of C would be. Of course, it is 2, 3, 4. Accepted. Can't it be 4, 6 and 8. Compare them. 4 is to 6 is to 8 is still 2 is to 3 is to 4. Can't it be 6, 9, 12? Yes. So now what is A? So it can be any value. It can't be any value. It depends. Now this 2, 3, 4 can be written as, okay, this 2 times 1, 3 times 1, 4 times 1. And this 4 is written as 2 times 2. This is 3 times 2. This is 4 times 2. Yes or no? And 6 is 2 times 3. 9 is 3 times 3. 12 is 4 times 3. Yes or no? So what do you observe now? So into 1, into 1, into 1. Into 2, into 2, into 2. Into 3, into 3, into 3. So finally, the value of A, the value of B, and the value of C will be some 2k, 3k, and 4k. And what is k? That's a very important question. What is the value of k? Where k is a valid common term. Where k is a valid common term. We'll speak about that in a minute, but for now copy it. K is a valid common term. Please copy it down. Copy that? Yes. Now, going forward, keep in mind whenever we express a ratio, see that the ratio is in the integral format, the integer format. I mean to say that if A is to B is given as 2/3 is to 3/2. When you have problem like this, then see that this ratio is in an integer format. So the story says just cross multiply and the answer would be 4:9. How did you get that? So LCM of denominators 3, 2 is 6. So it would be 2/3 times 6 is 2. 3/2 times 6. There is 3 2s, 2 3s. This is 4:9. This is one way of doing it, and this is the actual way of doing it. And if you can recall, in your school days, you have learned that A by B by C by D is same as A by B times D by C. Now can I write this as A by B is to C by D? So this will be same as AD BC. So it is AD is to BC. The same thing what I have done here, simply cross multiplying. You have learned this in your school days, right? And the topics of algebra where you invert things and the fraction gets inverted, the change of numerator and denominator is found. Similarly, if A is to B is to C is something like 2/3, 3/4 is to 4/5. So please convert this into the integer ratio by taking the LCM of the denominators 3, 4 and 5. So LCM would be 3, 4, 5, 60, right? LCM is 60. Now multiply the fractions with 60. So this is 3/20s, 4/15s, 5/12s. 40 is to 45 is to 48. The final ratio, and you cannot minimize it. Okay, please copy it down carefully. Is that fine? Yes. Done with this? Now, let us learn few things like if x is to y is a ratio, then if x is to y is a ratio, then its duplicate ratio, then its duplicate ratio is x square is to y square. Its triplicate ratio x cube is to y cube. Its subduplicate ratio is x power half is to y power half. People call it as square root of x is to square root of y. And the subtriplicate ratio would be x power 1 by 3 is to y power 1 by 3. People call it as cube root of x is to cube root of y. So four concepts: duplicate, triplicate, subduplicate and subtriplicate. Please copy it down. Is that fine? Yes. So we have seen what a ratio is. We have seen the duplicate, subduplicate, triplicates and subtriplicate, and we have seen what is the method of converting a fractional ratio into an integral ratio. Okay, so basically what do you mean, I mean, what is the concept of ratios in real life? For example, I want to divide some 10,000s. I want to divide some 10,000s in the ratio of 2 is to 3. The ratio of 2 is to 3. So you can solve between two methods. You can solve this in two methods. So assume that I want to divide 10,000s among A, B in the ratio of 2 is to 3. In ratios, we have different approaches of solving problems. Method 1 goes like this. Method 1. So the value of A would be some 2x, and the value of B would be 3x. So total is 2x plus 3x would be 5x. 5x is 10,000s. So x would be 2,000s. So A would be 2x. 2x would be 4,000s. And B would be 3x. That would be 6,000s. Isn't it? So A would be 4 and B would be 6. Now in method 2, the approaches. The share of A is 2 out of 5 parts. Total we have 2 and 3, 5 into 10,000s, and the share of B is 3 out of 5, 4,000s and 6,000s. So people have different approaches of solving problems. So this is method 1, method 2. I say that they are logically one and the same. How did you get this 2 over 2 plus 3? There are 5 parts on the whole. So if I move this 5 here, if it is 2 by 2 plus 3 into 10,000, if I move this 2 plus 3 here, 10,000 by 2 plus 3 is 2,000 into 2 is 4,000, and the same 10,000 by 2 plus 3 is 2,000 into 3 is 6,000. So approach may be different, but the final conclusion will be one and the same. People frame concepts from the basics, so learn the basics. Clear? So if you learn this method, you can do things without pen paper. You can calculate them fastly. So please copy it down. Is it fine? Yes. Now Now, the story is, a minute ago we have seen the word K. K is a valid common term. What do you mean by the word valid? The validity depends on the concepts you learn. For example, for example, in the story, uh, assume that I have dozen cups. Okay, and out of which few broke. Out of which few broke. So broken cups plus unbroken cups are dozen cups, which is 12. Now I want the ratio of broken cups is to unbroken cups. Okay. So case one, assume that we have 2 is to 1. Is 2 is to 1 a valid ratio or not? Is 2 is to 1 a valid ratio or not? So from this, I can say it as 2 by 3 into 12, comma 1 by 3 into 12, which would be 8 comma 4. So this is valid because you can have 8 broken cups, 2 unbroken cups, valid. Assume that I have a case of 5 is to 7. I have a case of 5 is to 7. So when I say 5 is to 7, it is 5 over 12 times 12, which is 7 over 12 times 12. So this would be 5 comma 7. Valid, isn't it? Yes or no? Now, the third case, if it is something like 2 is to 3, something like 2 is to 3. Now, this would be 2 by 5 times 12, comma 3 by 5 times 12. So, 12 by 5 would be 2.4. I hope I'm correct. Yes, 2.4. 2.4 times 2 would be 4.8. Would be 4.8. And 2.4 times 3 is 7.2. Now, can you have 4.8 broken cups? Can you have 7.2 unbroken cups? If it is with respect to cups, we have only an integer. You cannot have 4.8, 7.2 broken cups. So this is invalid. It means that you cannot divide 12 and the ratio of 2 is to 3 if it is cups. 12 cups cannot be divided in the ratio of 2 is to 3. 12 lakhs can be divided, 12 crores can be divided, 12 acres can be divided. So it is the objects on which you are working. I repeat the statement, you cannot divide 12 cups in the ratio of 2 is to 3 or 3 is to 2. That becomes invalid. Why invalid? Because common sense speaks that you cannot have 4.8 broken cups. It is either 4 broken cups or 5 broken cups, but not the range in between 4 and 5. Similarly, you cannot have 7.2 unbroken cups. It is either 7 or 8, but not something in between. So common sense speaks, right? So this is valid, this is valid, this is invalid. And as I told you earlier, so this will be your common term, right? 12 by 3, 4 into 2 is 8. 12 by 3 is 4. Right? 2k, 1k. 12 by 12 is 157. In this case, 12 by 5 is a fraction. And I don't say that the common term should not be a fraction. It can be a fraction, but depends on the objects you work with. Clear with that? So please copy it down carefully. An example with respect to validity. So finish copying this? Yeah. Let us do some small examples. Okay. Uh, P plus Q plus R is some 25 thousands. P is to Q is to R is some 3 is to 2 is to 5. Okay. So what is Q? What is R minus P? So what is Q? Q, the amount of Q. So Q gets two parts. Q gets two parts out of 10 parts. How you got 10? 3 plus 2 plus 5 into 25,000. So you can minimize it. This would be 5,000. Clear. Now R minus P. So R is 5 parts, P is 3 parts. So it would be 5 minus 3 by 10 into 25,000. So 5 minus 3 is 2, which is still 5,000. There is no need of calculating R separately and P separately and then performing the difference. Not required. You can do it directly. Okay, is that fine? And case 2. A is to B is to C is some 3 is to 5 is to 7. 3 is to 5 is to 7. If C is 21,000, if C is 21,000, okay, then what would be A and what would be A plus B plus C? What would be A and what would be A plus B plus C? So if C is 21,000, So from the ratio, the value of A is 3 parts, B is 5 parts, C is 7 parts. 7 parts is 7k. 7k is 21,000. So the value of k is 3,000. Done. And now what is A? A is 3 parts. So as A is 3 parts, 3 times k. So 3 into 3,000 is 9,000. And what is A plus B plus C? A plus B plus C is 3 plus 5 plus 7k. 3 plus 5, 8 plus 7, 15. So 15 into 3,000, that would be 45,000. That would be 45,000. So in ratios, you will be given the sum, the ratio, you will be asked to find the individuals, the differences, total values. Case 2, you will be given a ratio, you will be given one term, and you are told to find the remaining things. Is that fine? Please copy it down. Done copying that? Yes. Now let us move forward. The next model is solving fractional expressions. Solving fractional expressions based on ratios. So this is your case 3. Solving fractional expressions based on ratios. For this, the condition is to solve a fractional expression based on ratios, the condition is the power of every term in the numerator should be same as the denominator. If we are happy with this, if the condition is true, then it is a 1 second answer. Now what do you mean by that? Example 1. x is to y is some 3 is to 2. So question 1. So they'll ask you 2x plus 3y by 4x minus 2. They'll ask us 2x plus 3y by 4x minus 2y. So this problem has got many methods of solving, but let me give you the easiest way. Now, what is x? X is 3k, y is 2k. So 2k, isn't it? So 6k plus 6k would be 12k. 12k minus 4k would be 8k. So k and k gets minimized. 4 3 times, 4 2 times. So the answer would be 3 is to 2. So the answer would be 3 is to 2. Yes. So that is one way of solving it, the easiest way. Suppose you have a question like this. X plus 2y into 2x minus y by x square minus y square by x square minus y square. So what do you get? I'm not applying my logic here. I'm doing it the normal way of solving it. So the value of x is 3k plus 2 into 2k into 2 into 3k minus 2k by x square is 3k square minus 2k square. Now this would be 3k plus 4k is 7k. So 6k minus 2k is 4k by 9k square minus 4k square. 7 fours 28, 28k square by 5k square. K square is minimized. 28 is to 5. This is the normal way of solving it. And whenever you solve in this method, see that at the end of the problem solving, the common term should be minimized. The common term gets minimized. What remains? The value gets remains. Clear? Now let us apply the same story by using the condition. By using our condition. What does the condition say? The power of every term in the numerator should be same as the denominator. So x power 1 valid, y power 1 valid, x power 1 valid, y power 1 valid. So this problem can be solved. So condition is true. Condition is true. So substitute directly x as 3, y as 2. So it becomes 2 into 3 plus 3 into 2 by 4 into 3 minus 2 into 2. So it becomes 6 plus 6 12, 12 by 8. So it becomes 3 is to 2. Got it? Now this story. The power of every term in the numerator should be same as the denominator. So what do you mean by that? X is 1, y is 1, x is 1, y is 1. So you got x plus y into x minus y. Forget these coefficients if you even have them. So x into x is x square, x into y is xy. Xy is again x power 1, y power 1, 1 becomes 2. So yx, y power 1, x power 1, again 2, y into y, y square. So all powers are 2, right? And x square, y square. So again all the powers of are 2. So it means that all the powers are same both in numerator as well as denominator. So again the condition is true. Condition is true. Hence substitute x as 3 directly, y as 2 directly. So it becomes 3 plus 2 into 2 into 2 into 3 minus 2 by 3 square minus 2 square. So it becomes 3 plus 4 7, 6 minus 2 4 by 9 minus 4. This is 28 is to 5. 9 minus 4. So once the condition is true, problem solving becomes easy for us. You need not plug in always k and solve it there. Okay. So let me go for the third example. The third example is like 2x plus y into x minus 2y by 2x cube plus 3y square. Now it means that now again see here x power is 1, y power is 1. So x into x square power is 2, xy, xy. So x is 1, y is 1. So 1, 1 will be 2. And y into y is y square, power is 2. So in the numerator, all terms has a power of 2. 2x cube, the power is 3, and y square, the power is 2. The powers are not matching here. Are they matching here? No, they are not matching because they are not equal. The exponents of the numerator and the denominator should be equal. As they are not equal, it this can't be solved. It cannot be solved. Why? We'll see it in a minute. So please copy it down carefully. So now this problem 2 into 3k plus 2k My mistake, it is some 3x. 3 into 3k minus 2 into 2k by 2 into 3k cube plus 3 into 2k square. Now this becomes 6k plus 2k, 8k. 9k minus 4k is 5k by this becomes 3 cube 27 to 54. It is 54k cube plus 2 square 4 12. So it is 12k square. So 8 5 40k square. If I take out k square common here, it becomes 54k plus 12. So k square remains. It becomes 40 by 54k plus 12. And as the common term k is not minimized, so this problem can't be solved. This problem cannot be solved. Why? Because we have k here. You need not do all these things. Check the exponents.